Good morning. Today I will continue our lesson which talking about radian measure, and I will discuss today how can I find the length of an arc of a circle. To find the length of an arc, I need the radius of the circle, and also I need the measure of the central angle in radians. So if I have now this circle, for the circle now, I know its radius, r. I know the measure of the central angle, theta. And you have to know that this theta, it must be in radian. To find now the length of this intercepted arc, I will use this formula. The intercepted arc S is the radius times the measure of the central angle in radian. This is how can I find the length of an arc. Now, as an example, in problem number 3, page 838, if you have now this circle, okay, you have now this circle, approximately it's a circle, okay. For the circle now, I'm sorry, okay, you have a radius here, which is 3 inches. We have also just like this. Now, I told you that here you have 5 pi over 6. Here you have 2 pi over 3. Here you have, we name it with S. Here name it with B. And here with W. For this one now, if I told you now, find the length of an intercepted arc S. So S is equal to the radius, which is a 3, times here. For this an intercepted arc, which central angle is an opposite to this arc? 5 pi over 6. Bravo. So 5 pi over 6. By simplifying, it will be 5 pi over 2. Now, here to find this length of an arc as a number, for this pi, you will not use 180 as we discussed yesterday, because this 180 is only for angles. I will use pi, which is equal pi, which is equal 22 over 7, or 3.14, which is we use to find to use it in circumference or the area of a circle. So here, S it will be 5 times 3.14 over 2, which is approximately 7.9 inches. So the length of an arc S is 3.14. What about arc B now? For arc B, it is the radius R times, for this arc B, which is angle is an opposite to it, 2 pi over 3. So 3 times 2 pi over 3, it will be 2 pi, which is 2 times 3.14, which is 6.28 inches. So the length now of an arc B is 6.28. How can I find now the length of an arc W? I didn't have any angle. To find now the length of an arc W by using oh sorry, by finding the circumference of the circle. So the circumference of a circle is 2 by r. So 2 times 3.14 times radius r, which is 3. So the circumference of a circle is 18.84. Okay, so after that, I have now the length of S, I have now the length of B, I have now the circumference of a circle. So now I can find the length of an arc W. So W is the circumference, which is 18.84 minus 7.9 minus 6.28, which it will be 4.64 inches. So the length of an arc W is 4.64 inches. Okay, now all of you please go to page 840 to solve some of the practice and problem solving exercises. Write each measure in radians. In number 6 here, we have negative 300 in degree, and I want now to write the answer in radian. So here, negative 300 multiplied by, I want radian, so by over 180. 0, cancel 0. 18 over 3 is 6. 10 over 3 is 30, sorry, over 3 is 10. Over 2 is 5. Over 2 is 3. So the answer is negative 5 by over 3. So negative 300 in degree is equal to negative 5 pi over 3 in radians. What about number 10 here? 160. 160 multiplied by over 180. 0 cancel 0. 16 over 2 is 8. 18 over 2 is 9. So it is 8 by over 9. So 160 is 8 by over 9. Now here, write each measure in degrees. If you have it in radians, like 11 by over 10. I will put 11 by over 10 multiply by, I want the answer in degrees, so 180 over by, cancel by, then 0, cancel 0, 11 multiplied by 18 is 198 degree. So here 11 by over 10 is equal to 189 degree. 7 by over 4. In number 41, 7 by over 4 multiply by 180 over by, cancel by. 4 over 2 is 2, 180 over 2 is 90. 90 over 2 is 45, over 2 is 1. So 7 multiplied by 45, which equal 315 degree. So 7 by over 4 is equal to 315 degree. Now, use each circle to find the length of an indicated arc. Arc T. To find the length of any arc, I will use the radius r times the angle in radians. R, the radius here is 3 centimeter, multiplied by over 3. 3 cancel 3, so it is by. Then I will know that, as we said, by is equal to 22 over 7 or 3.1 4. So it is 3.14 centimeter. So the length of an arc T is 3.14 centimeter. What about A now? Here, this arc A, it has this angle. So 6 inches multiplied by 4 pi over 3, which is 8 pi. So it is 8 times 3.14, which is approximately 25.1 inches. This is now the length of an arc A, 25.1 inches. Now, open your book, page 842, exercise number 57, SAT preparation. In this question here, two arcs have the same length. One arc is intercepted by an angle of 3 pi over 2 radians in a circle of radius 15 centimeter. So here we have a circle with a radius of 15 centimeter and an angle of 3 pi over 2. Now this arc length is equal to another arc in another circle, but here its radius is 25 centimeter with an angle which is unknown. Now, here, so this arc is the same as length of this arc. Find the angle which is unknown. Since these two arcs have the same length, so here we have S1, here we have S2. So S1, it's R times theta, which equal to R times theta. Radius 1, theta 1, radius 2, theta 2. Now, the radius of the first circle is 15 times 3 pi over 2 equal to R2, which is 25, times theta 2, which is unknown. So here, from this question, I have to use the given that these two arcs have the same length. So since that these two arcs have the same length, I can use theta 2. Okay, 15 times 3 is 45. 15 times I is 45 by over 2 is equal 25 by 2. Then divide by 25, divide by 25. So 45 by over 2 multiplied by its reciprocal 1 over 25 is equal to theta 2. Then divide by 5 is 9, divide by 5 is 5. So it is 9 by over 2 times 5 is 10. 9 by over 10, which is B. Okay, now thank you for listening. Please, you have homework number 37, 38, 39, 41, 42, and also 11, 8, and 12, and 28. Okay, send me these questions, the solving of these questions, please,